This is the review for Unit 4. So number 1, how much simple interest does $318 investment earned at 9% over 1 year, which hopefully no one's borrowing, well, it's an investment. You're going to earn money on this. So you're investing $318 and you're earning 9%, which is pretty good for you. So it says simple interest, so we need to keep that in mind. So we're using I equals PRT. We're going to find how much interest, so 318. We do need to change 9% to a decimal. Remember how we divide percents by 100? We'd end up with 0.09 times 1 year. And if we actually go through and multiply those out, the amount of money that we earn is $28.62. So not bad for 1 year and not very much money. If you borrow $421 for 9 years at an interest rate of 3.8%, how much simple interest do you pay? Again, simple interest, same thing. So 421 times the 3.8%, again, divide it by 100. We end up with 0.038. And then we times it by the number of years. In this case, 9 years. And if we do that, we have $143.98. Again, the rate that we were investing or borrowing, was a lot less than the last problem, and so that's why we don't. We're seeing that it was over a lot more years, though, so that's how we get more money. Number 3. If you borrow $630 for 1 year at an interest rate of 3.8% compounded monthly, how much do you owe on your loan after 1 year? So compounded monthly, and it's for 1 year. So we're going to use the compound interest formula. So A equals the amount is going to be 630 is what we borrow. And then we put 1. If it's interest, it's 1 plus. And it's the rate as a decimal. So again, 3.8% is 0.038. And if it's compounded monthly, there's 12 months in a year. So the T that we use, since it's compounded every month, is 12. And if we actually multiply all that out, the amount that we are going to owe is $985.62, which that's with taking out borrowing $630, and now we owe $985. So not so great to have to borrow money. $400 is our principal, or the invested, and it's 1. Again, this one says it's compounded monthly, so I'm not using simple interest, I'm using compound. And it's 9%, so 9%, again, we have that 9% right there is 0.09. And it says over 3 years, but it's compounded every month. So how many months are in 3 years? Well, 3 times 12 is 36. It's 36 months in 3 years. And if we go ahead and figure that out, we'd end up with $8,900.49. Huge amount of money that we owe now. But again, it's compounded every month. And it's at a rate of 9%. That's a pretty big rate. Pretty big percent. The next one, if you borrow $225, again, this one is compounded yearly, so I knew that I was using the A equals P because it's not simple interest. So A equals 225. And then 1 plus our rate on this one is 6%. So if you divide by 100, you get 0.06. This is compounded yearly, and it's for 8 years. So if it's every year, compounded yearly, I just use years. And if we multiply it out, we end up with $358.62 is how much we owe after 8 years. Um, then a car costs $12,500. It decreases in value. So again, we're going to use the same equation, but it's decreasing in value, so we're going to subtract our percent instead of adding it. And then it's per year, and it's for 4 years. So 4 years is our exponent, and if we multiply it out, our car is now only worth $9,759.36. If we do that last one on that page, number 7, it's a little bit easier to just move this up. So a house costs $205,000 and decreases in value 2.5% per year. So again, this is A equals, it's not simple interest. It's decreasing in value, so 1 minus, and it's 2.5%. If we divide by 100 again, that's 0.025, and it's per year for 10 years, so exponent 10. If we actually go through and type that in the calculator, multiply it out, we get $159,407.57. So that would be the value of the house after 10 years. So if we go back here, undo that, sorry. So we're up here at number 8. It says find the rate of change for each of the following. It says 7 plus 6x. Again, this is the same as just y equals. Notice the mx is right here, so this is b plus mx. And we're looking for the rate of change, or m. In this case, it matches up with 6, so that's it. It's just 6. Number 9, notice that that one starts at 2 and is multiplying by 5 every time, which means if you graph that, starts at 2 and it's multiplying by 5, notice that's exponential. This is not constant. It does not have a constant rise and run. Notice it's changing every time. The next one, notice this is not y equals, so we can't just say mx plus b. We have to actually solve it. So here we're going to solve it for y. And the first thing we need to do is subtract 7x over. Notice I'm putting the 7x next to the 12 because they are not like terms. So we have 6y equals 12 minus 7x. If you divide out 6 on everything to get y alone, we have y equals 12 divided 6 is 2. 7 divided 6 is just 7 over 6x. And if you are picking out the slope, just like the one on top, notice that we're looking for the slope. That's the number next to the x here, mx, b plus mx. So our slope is negative 7 over 6. Number 11, if we actually distribute and simplify this a little bit, we got y equals 7 minus 6x. Negative 6 times negative 8 is positive 48, so plus 48. If you combine like terms here, we got y equals negative 6x plus 55. And that's mx plus b. So again, we're looking for the rate of change, the slope, and that's negative 6. Number 12, graphing 81 times 2/3 x. I can start at negative 2, I could start at negative 1. I'm going to do just one negative number this time. And from here, notice this is our x-axis and this is y. And I know right away, and you could actually plug in 0 for x, but you also should know that the 0 term is 81 and that it's timesing by 2/3 every time. So if you times by 2/3, or you can again plug in a 1 for x, you get 54, plug in a 2, or just times by 2/3, 36, 24, and 16. And then if you go backwards here, or plug in a negative 1, you end up with 121.5. So when you're graphing this, you need I chose to put in a negative 1, so I need to have my graph go all the way up to 121. And so that's about 120. So maybe I went by 20s on my graph. So maybe 20, 40, 60, 80, 100, 120, 140. So then negative 1, 121. So that's about negative 1. 121 is about right here. 81, 0, 81 is about right here. 154 over 1 up 54. 236, that's 20, so 36. 324. 36 probably a little higher, 24. And then 16, a little lower. Notice now we'll end up getting numbers that get closer and closer to 0. Remember that this will not cross down into the negatives. They just get smaller and smaller. So yes, your line should curve and it should look something like that. Circle which words match the function above. Well, if you notice that our line is going down, or as you go across the page from left to right, the numbers are getting smaller in our table. The line is also going down. So that's decreasing. And there's an x as an exponent, so we can definitely say that's exponential. Why did you choose the words? I said decreasing, the numbers are going down, or multiplying by 2/3 gives you a smaller number. Exponential, because there's an x as the exponent. Backside on here, we've got circle whether it's true or false. The rate of change between the following points, 10, -3, and -29, is 1. So here we're going to make a table. We're going to find the rate of change, 10, -3, and -29. Find the slope. So bottom minus top. If I do -9, 9, take away a -3, notice that that's the same as adding. So 9 plus 3 is 12. On this side, we got -2, take away 10. So I'm down 2, down 10 more is down 12. So I got rise over here, run over here, 12 over -12. If you divide those out, you get -1. So look at the answer here. It says it's a positive 1, so we have to say that this is false for the answer. The next one, I would do the same thing. I would set up a table and find the slope and see if it matches up with the answer given. So on this one, we've got 4, 9, and -1, -1. Bottom minus top, -1, take away 9. That's more negative, so it's -10. -1, take away 4 more negatives, so it's -5. So if I divide these out, -10 over -5, negative makes positive, and 10 divided 5 is 2. So it's a positive 2, and that's a positive 2, therefore it's true. Be very careful with your positives and negatives on this problem. That can mess you up. Next one, we want to decide whether it's linear, exponential, or neither. So